Hey everyone, Sebastian here, back again with more SAT math. We're going to do 3 algebra questions today and cover everything we need to on those. These are questions that I think are very helpful to understand for the SAT coming up, especially in September, but always useful in general. They're not exactly questions I think I'm predicting. I've done a video on predictions already. This is more about questions I think are just useful to know, covering concepts that are useful. So let's try these out. But before we get there, I want to show you the resource I've been developing to help students sort of map out the types of questions on the SAT. It's totally free, and you have a link in it in the description of the video, but I just want to show you the sort of project that's going on when you come watch these videos. They're not just one-off videos. There's a larger scheme occurring bit by bit. So basically what I've been doing for the last year is developing question types, studying the question bank in the SAT and going through and breaking them down into specific types. So for instance, the percentages, I've already done a full walkthrough. You can watch that video in your own time. And when I made this, there were 67 total percentage questions in the question bank. Now you could go through all 67 questions and do them, but I broke them down into specific types. There's P, R, E, A. So the E's are all the easy categories. Then you have the M's, which are all the mediums. And then you have the H's, which are all the hards. Now, I have video examples for many of them, and that's a project I'm doing where I'm doing them all out. And that's what the walkthrough is. The walkthrough does a full walkthrough, one question for each type. And now I'm doing more thorough, shorter videos where I do a few questions of each type or 2 questions. Now, what I want you to understand is that this is helpful not only because it breaks it down and teaches you things, but it helps you see what's going on. So like in PRMJ, it's a medium level question where you have to find a number as a percent of another. PRMI is find a number after a percent change. And if you notice that pattern, you understand those are 2 different types of questions, and you'll know to look for that and identify which type you're doing when you see a percentage question. And I'm not doing it just for percentages. I'm done for evaluating statistical claims, inferences, probability and conditional probability. And I could just keep going. There's a walkthrough on this as well. I just haven't put it in the actual thing, but it's in my YouTube channel. And I'm going to be doing it for everything. So if you do this and you go through these, you'll have a better understanding of the types of questions you'll see on the SAT. And if you can identify them on the test, you'll be faster and more accurate. So that's my little spiel on this totally free thing. It's on a Substack. And now back to the questions. Functions f and g are defined as f of x equals 0.8x minus 7 and g of x equals 3/4 x plus 5. What is the value of the x-intercept of the graph y equals h of x if h of x equals f of x minus g of x? So I'm going to make this into 0.75 as a decimal, and I'm going to subtract it because that'll give us the h of x value. So we'll do 0.8x minus 7 minus 0.75x. Now because it's negative, I'm going to also make the plus 5 into a negative. It'll be like this. And then I'm going to get 0.05x minus 12 equals h of x, which equals y. Now it's asking for the x value of the x-intercept of the graph. So y equals 0 at the x-intercept. So we're going to have 0.05x minus 12 equals 0. 0.05x equals 12. X equals 240. The other thing you could do is just plug in the original equation into Desmos. I'll show you that right now. So in here we'll do 0.8x minus 7 minus 0.75x minus 5. Let's zoom out, let's see, and 240. So that's all you have to do for that as well. Honestly, I would do it this way. The way it works for me is I would make the equation and solve it in my head. I wrote it out for you all, but if you can do it in your head, that's even better. But if you can't do it in your head and you want to do Desmos, honestly, that's great too. They're both perfectly fine. All right, so now let's do this one here. 4x equals 44y plus 36. Which of the following equations, when in a system of equations with the equation above, will create a system with no solutions? We have A, 3x plus 4y equals 6x minus 14 plus 5y. B, x equals 11y plus 9, C, Lx equals 11y plus 12, D, 6x equals 66y plus 54. Now, what some people might do is plug in the original equation, plug these in, and see which ones never cross. But there could be a very slight difference, and you have to check for a long time. So I'm just going to use the concept. What's the concept? For them to have no solution, they're going to have a different y-intercept, so like this values will be different, but this will have the same slope. So if you notice here, from 4 to 44, it's an 11:1 ratio between x and y when they're on different sides. I'm going to leave A alone because it's more complicated to get into the picture, and I'll do the others. So here we have x and 11y, so that makes the same type of slope because y is 11 times, the coefficient on y is 11 times as big as the coefficient on x. So that's very tempting. But if you notice, C also has the same thing. So what's the difference? We have 9 here and we have 12. Now 9 is 9 times the coefficient on x. 36 is 9 times the coefficient on x. So actually B is a simplified version of the original. So they're the same equations. So instead of no solutions, they would have infinite solutions. C, however, has no solutions because these have the 11:1 ratio, but this is a 12:1 ratio, not the 9:1 ratio. So there's a different y-intercept and you'll get C. What was wrong with D? 11:1 ratio with the 6x and 66y, but still a 9:1 ratio there. And then A we don't have to work out because it just ends up not mattering. So that's how I would tackle this question. Remember to use the answer choices to help you sometimes and compare them to each other and sort of have your spidey senses going. Why is x11 equals y? What's the difference between B and C? And then help that guide you in your work. And don't do A, we don't have to, until the very end because it's just more work. So start with something easy and then go from there. And you might not have to do it. And this one we didn't have to do it. Great, so now I'll have one more for you all and we'll be set. All right, we have this one here. There's a lot of words, but hopefully it's not too bad. Hector can either bike to work or take the train. The train takes 6 minutes and the bike ride takes 21 minutes. The train arrives every 30 minutes, so the number of minutes Hector will wait can range from 0 to 30 minutes. If W is the number of minutes Hector has to wait for the train, which of the following inequalities gives the value of W for which it would be faster for Hector to bike to work? Okay, so when is it faster for Hector to bike to work? What I'm thinking is there's a 15-minute difference between the 20-minute bike ride and the 6-minute train ride, right? That's a 15-minute difference. So anytime he has to wait more than 15 minutes, so when W is greater than 15, it's faster to bike to work. So which of these gives us that? So A would give us W is less than 15, that's close. B would give us the W is greater than 15, so it should be B. C is W is less than 27, and D is W is greater than 27. So it is B, and that makes sense. We're using the 6 minutes from the train ride. We're going to add that onto the wait time and see if it's greater than or less than the 21-minute bike ride. Okay, so this one's very conceptual, but look at the answer choices first to guide you. That's what I did. They all look very similar. And then work from there and try to think about the real world implications to help guide you, right? It's not so abstract if you think about how it's actually working in reality. All right, I hope you enjoyed this video. I've done other ones on geometry and advanced math, and I'm going to do one on data analysis and problem solving. So you should have a full range of questions to review before the test to feel good going into it. All right.